Okay, so here we're doing another optimization workshop. This one's a little bit complicated, but it's worth reviewing. You'll notice it takes 363 seconds. The idea behind this one is that it's looking for, since January 17th, which might be when this first started. It does have some optimizations in here already, like date filters and stuff. Looks like they're looking for the transaction. Let's go bottom up. They're looking for the distinct number of transactions and the unique number of wallets for the transactions that have an action that includes this action. So the number of transactions that do this and the number of unique people that do this. And you can tell because there's a join on the transaction IDs between, all transactions be. Okay. So yeah, let's see if we can beat 363 seconds. You'll also note that this is non-reproducible. That just means that depending on the day you run it, you get a different result. So this was updated 2 days ago. Let's see if we can get close to these numbers, as of 2 days ago, which is the 6th. So let's go ahead and fork this query. And okay. So let's start with moving this to a comment. So we can run things in some pieces. The goal is to beat 363 seconds. And then the numbers we're trying to get to are roughly 6 million transactions and 430,000 users. Okay, so let's go ahead and start with just grabbing a quick transaction and seeing what it looks like. And let's grab everything from here. Grabbing all the columns for a few of these transactions just to see what they look like. It's always good to know what you're looking at. So there's transaction ID, transaction succeeded equals true. I just like to put that directly. Let's see. Yeah, not too much information. We just know that this action happened and there's a transaction ID. So let's tweak this slightly. And now let's look at everything for this transaction. And for simplicity, we also know this happened on this day. Okay. So we saw this transaction as the Cosmos Bank message send. Let's see if it also has a message type transaction and a fee pair. So transactions should always have fee pairs, but more transactions will have fee pairs than have this. And I guess it's technically possible that maybe this could happen without a fee pair. I'm not totally sure. Okay, so yeah, a lot of stuff's going on. Bank module, Cosmos Bank V1 beta, a lot of stuff going on. Let's see if there's fee pair. There's a fee pair. Okay, looks like there's one fee pair. Let's see this. So message type transaction, attribute fee pair, attribute key. Okay, so really, this isn't a fun optimization because the answer here is to scan less, and to scan less you have to do more complicated things. So I like CTEs that are very readable. Here's all the transactions. Now grab the fee pairs where this is also true. The answer here, they join at the end. The optimization answer here is really to join at the beginning, to join it to itself. That way you're filtering, essentially you filter these transactions and then join it to its own table where this is also true. And you do an inner join, that way they both have to be true. So let me go ahead and write this really quick. Okay, so this is kind of ugly. We'll see how long it takes to run. And while it's running, I'll tell you what's happening. So all I did was I just grabbed it twice, and I'm joining it to itself. So I'm grabbing the attributes once, and then I'm grabbing it again, and I'm using transaction ID. And then what I'm going to grab is I'm going to grab the distinct number of transaction IDs and the distinct number of fee pairs And you'll notice that it's C2 here, and the transaction ID doesn't matter because it's the join. So in the first scan, look for a message attribute message, action, this value, and that it succeeded. And then you only have to do this once because it's an inner join. And then this is for speed. This one is saying inner join it on the second CT essentially. And again, you do this for speed. And it was 20 seconds this time. And we got slightly higher numbers because we're running it today. But yeah, I mean, this was mostly a scanning thing. So again, the reason this is a lot faster is because you're just going to the tables kind of together without making a CTE, then making another CTE, then doing the discounting. You can do this at the same time you're scanning this. You don't have to make it and then count it in the methods that we're using. And then again, you don't have to count it again. So essentially, you're just trying to count once is the secret to making this faster. But yeah, it's definitely not a fun looking query, but this is how you would optimize it if you can't afford readability. I like this because it's readable, but if you have to go for speed, this is the kind of stuff you end up having to do. But yeah, 360 seconds down to 20 seconds. And then yeah, we're pretty close. And the reason these are different again is because I'm running it on a different day than they ran it. So yeah, let's look out for the next optimization.